one, go.
So because that there's each set of 3, you multiply 3 by the stage number, like how this is stage 1 and it's only one set of 3, etc. And then you multiply that by 4 because there's 4 sets of 3 on each side. And then you add it by 9 because that's the amount in the middle.
Excellent. All right. Will that account for all of the blocks in each one? Let's see if we can touch that. So you said here's a 3 times 1. And why do you have times 4?
Because there's 4 on each side.
Okay, so if I were to remove those, which are kind of hard to do, but if I were to remove those, that would account for, yeah, those things are tough, right? Okay,
Yeah.
we'll do it hypothetically. Okay, so all right, here we go.
Oh my goodness.
Is it because there's another block on the side attached to
Most
It could be.
likely.
We'll use it. Let's cross them out. Let's use a marker. We'll cross them out. Okay. All right. So that accounts for 1 set of 2 sets, 3 sets, and that's our 4th set. So that's the 4 sets of 3 times the pattern number. And the pattern number here was 1, so that's 3 1s 4 times. Now what do we have here? We have 3.
We have 2 sets of 3 here.
Okay, so that's 3 2s. How many times?
Here,
4 times.
4 times.
Okay, and then we could say here we have 3 sets of 3 4 times.
Yeah.
Awesome, so we see
And
that
then-
connection there. And then what?
And the stage number what n is,
Mm-hmm.
since it doesn't stay the same.
Excellent. And where's the 9 from again?
Well, the around in the middle.
Okay, so each one of these patterns, after you cross out those 4 sets of 3 times the pattern number, they all have that 9 left in the middle. All right, so if we were at the 100th stage, how many blocks
You
are
would
there?
have to multiply 100 by 3, which is 300.
Mm-hmm.
And then multiply that by 4, which is 300 times 4 equals
1200.
1200 plus 9 equals 1209.
Excellent. Great collaboration. Very, very well done. So what we were going to continue to do was take this and make a table and make a graph. And Sharad, I know that you made your table and your graph. What did you notice about your graph? Because we're going to pick up on this tomorrow. What did you say about your graph?
So
Tuesday.
I guess it increased not by the same number, so it didn't increase by 2 each time.
Uh-huh.
It first increased by 7, then 9, then 11, then 13. So it wasn't a straight graph. I forgot the word. It's like
It has the word line in it. Linear.
a linear graph.
Nice. It
Yeah.
wasn't linear.
There's a slight curve.
Nice. And how can you tell whether a graph is linear or not?
If it is it starts from 0. No, if it's a straight increase, or it increases by the same number.
Excellent. And if it increases at the same amount, it makes that
Increase.
that straight line. That straight line. Excellent, excellent, excellent. Ariana, is there anything you would like to say about yours before we head out? I know you discussed it earlier.
So how it is it's the equation is pretty much n times 6 plus 1,
Mm-hmm.
because the n is the amount of is a stage, or the amount of squares on each side,
Mm-hmm.
and times 6 because there's 6 sides, plus 1 because there's one hexagon in the middle.
Mm-hmm.
And the graph, I'm not really sure if it's linear or not. Kind of looks that way.
Okay. In order for it to be linear, Sharad, what would you have to say about the increase?
Well, the increase, it looks the same because it's 7 plus 6 is 13, then 13 plus 6 is 19, and then so on. And so, yeah, it would be straight.
So it would be a straight line?
Yeah, it would be able to.
All right, we can definitely test that out using technology. The next time we're here, we'll plug it into the computer and see if it produces a straight line. Yes, great job. We're going to clean up. I'm quite proud of you guys today. Great job.